Hi, my name is Amanda Bentley, and my lab is on the photoelectric photometry of the Pleiades. So in this lab, we're going to do a general overview. So we're going to use a simulated photometer to measure the apparent magnitude of stars. And when we get those results, we're going to use that to be able to design an HR diagram. And to come to our conclusion, we have to measure the relationship between the apparent and the absolute magnitudes. And from there, we're going to use those numbers to calculate the distance to these star clusters. So we have a data of about 40 stars, and they're collected within the Pleiades cluster, and we're going to use this to be able to find the apparent magnitudes. So we have to assume that all stars are the same distance away from each other, because if we don't do that, then we cannot consider the impact that it has on the magnitudes. All right. So we collected the data of about 40 stars to find the age using a photometer. We found the B and V values, and then we subtracted them, the B from the V values, and this is how we created our HR diagram. So following that, we adjusted our M&M and EB minus V to be able to line up within the cluster. It's creating a line of consistency that goes through it. And then we find our age. We look where the sequence started to turn off. So the MSTO, which was about 0.1. So 0.1 equals an H5 star that has a mass of about 2.0. So the formula we use to calculate that is shown on the board. All right, so now we're looking at our cluster. So our results, M minus M equals 2.0, and E, B minus V equals 0.2. So if you look here, so we're going to take a look at this and go back to the graph. So we adjusted the M minus M and EBV, which is the yellow triangles, to line up, and the blue squares represent the star cluster. So then it gives us the 0.1 for our MSTO. So if we look at that, there's our blue squares, and then our yellow triangles is that kind of like center line, the medium line. Okay. So overall, the age of 1.77 times 10 to the 9th years old makes sense generally for the data that we were given. It could be off a little bit due to the lighting difference. We collected this data over 2 different day periods, so obviously the sun and the lighting does change. We assumed all stars were the same difference and distance, and this can also impact the results because all stars are generally not the same distance apart. Comparing this to other students, our graphs and data do look alike. I don't think there was anything that was extremely out of the ordinary, so I believe that our results are accurate. And this is the Pleiades cluster.